Hey everybody, welcome to the last part of section P5, which we hinted at the last video, but I kind of wanted to save a whole new video for this because it is very, pardon to say, complex. So we're going to learn about complex fractions. What are they and how the heck do we simplify these? Well, just look at these monsters. Holy cow. A complex fraction is basically a fraction within a fraction, where either or both the numerator and denominator are fractions. Ugh. Well, the good news is if you look at this right-hand side, it's not as bad as it looks. Because what we're doing is we're basically just taking one fraction on top, dividing by a fraction on the bottom. And remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So that's what we're going to use today. But sometimes the fractions are kind of nasty and we're going to have to simplify the fractions within the denominator and numerator first. For example, if you look at this one here, I need to get that into one fraction first, common denominator, and get this bottom one here, this one, into one fraction, common denominator, before I flip and multiply by the reciprocal. So in terms of order, so we know what complex fractions are. Our goal is very simple. Let's simplify the numerator into one single fraction. Let's simplify the denominator into one single fraction. And then once you've got that, then you're good to go, right? Dividing a fraction by another is the same thing as multiplying by the reciprocal of the bottom, right? And then we should check our domain, always, always. And then if there's any kind of simplifying that we can do at the end, whether we can factor and cancel, let's do that. All right, so the first big step is we need to make sure the top and the bottoms are one single fraction. If they are, then we can go right away and multiply by the recip. But before we cancel, we should be checking our domain, making sure we're catching all the bad values before they escape. And then finally, we'll do all the simplifying that we've done this entire section. Okay, let's play. Here we go. Here's this first one I talked about. So again, the first goal is try to make the top into one single fraction. Do you see right now it's made up of two? So we're going to find a common denominator and do everything we did in the last video. And the bottom, we have to make this into one single fraction. Notice that that's also 2. And then we can think about inverting and multiplying by the recip. Okay, why don't we just play with the top here, friends? Here we go. Come on, buddy. Okay, let's simplify this into one single fraction, which means I need a common denominator. But first of all, it's hard to see, but do you see that 3 has a denominator? It's just 3 over 1, right? Okay, so what would be a good common denominator? My LCD here would just be x times 1, or just x. Okay, which means I need to multiply. The left one's okay, I think. But the right one, I need to multiply top and bottom by x. That gives me 2 over x minus 3x over x. Great. Got my common denominator? Sweet. So we can put that into one fraction. There's my denominator. And unfortunately, 2 and 3x don't combine very well because one's got an x and one don't. So that one's good to go. Leave it for dead. Okay, let's do the bottom. Let's do the denominator. Same steps here, friends. We're going to do 1 minus 1 over x minus 1. Okay, we need a common denominator, which you can see the single 1 is just 1 over 1. So here, my LCD is just going to be the 1 and the x minus 1. So it's basically just x minus 1 is my common denominator. Okay, which means I need to multiply. The right fractions are good, right? But the left one, I got to multiply by x minus 1 to change it. All right, what's this looking like? I've got x minus 1 over x minus 1. That makes sense. That is equal to 1, right? Minus 1 over x minus 1. Great, common denominator, we're good to go. X minus 1 is my common denom, and I basically just have x minus 1, or x minus 2 over x minus 1. Okay, that one's good to go too. So look what we have here, folks. Let's rearrange it now. This new complex fraction was this up on top, right? Massive. But now the top really, really is this. And the bottom really, really is this. Okay, that's great. Look, we've got one fraction on top, one on the bottom. We can ask the eternal question. Dividing by a fraction is the same thing as here we go. All right. 2 minus 3x over x, and we're going to always recip the denominator, right? We don't flip the top, we recip the denominator. Okay. Now, before I think about canceling, shall we talk about domain for a second? Okay. Let's look at every single spot. There's a denominator, like everywhere. Okay. We can even go back to the beginning. We can go back to where we are now. Me thinks I see a denominator here. So x cannot equal 0. I see a denominator here. So x cannot equal 1. But remember, we flipped this. And when we flipped him, he gave us a new denominator. Oh, joy! So therefore, x cannot equal 2. So before I think about canceling, let's do denominator first. All right, good. Now, is there anything that I can cancel either top and bottom or diagonally? And unfortunately, if you look at all these factors, there's nothing more that you can do. There's nothing common, entire common factors that you can cancel top and bottom or diagonally. So we're just going to leave it as is. We're not going to distribute. We should always try to keep things factored because maybe, just out of good practice, something might cancel down the road. So for now, that's my final answer. There you go. Okay, so let's look at our steps one more time, friends. We tried to turn the numerator into one fraction. We turned the denominator into one fraction. Then we could do the trick of dividing by fractions, multiply by their SIP. We checked our denominator over here, step 4, looking at every single denominators to find domain. And then if there was any canceling or simplifying, that was our last step. Okay? That's your first one. Should we try number 2? All right. So see if you can try it on your own, friends. It's not that bad, right? Just try to make one fraction on top and one on the bottom. Why don't you see if you get that far, and we'll see if we match up, folks. All right, number 2. Here we go. Now I got a little bit of room over here. We're going to put this guy over here in isolation. Let's just look at the numerator. We have x over 4 minus 3 over 2, and that's actually a plus. Stay positive, Mr. B. Okay. LCD. Again, 4 times 2 is fine, but is there a better denominator that's the lowest? And it actually is just 4. So the left fraction is coolio, but why don't we multiply the right fraction, top and bottom? Okay, so we got our common denominator, we're good to go. And top, we just have x plus 6. That's all we can do with them. Cool. How about this friend over here? 2, and I already know that I'm going to be adding and subtracting fractions, so I'm just going to write that right away as 2 over 1. Okay, LCD, I've got an x and a 1, so it's just x, which means I need to multiply this friend by x top and bottom. Okay, that gives me 2x over x minus 3 over x. Cool. Well, again, that numerator kind of stinks. Denominator is good to go, but the numerator is just 2x minus 3, and he's good. Okay, let's bring our numerator and denominator all together. Here's our new numerator. Here's our new denominator. Okay. Remember the trick. Dividing by a frac is the same thing as Great. Okay, before we think about canceling anything, let's have a little domain chat, shall we? Okay, let's find every single denominator. Ready? Okay, that's a 4. Okay, a 4 can never be equal to 0, so we don't have to worry about it. Basically, there's no x, so we don't have to worry about what x value would make that denominator 0, because he's just a 4. But I'm looking down here, and that would give us a 0. 0 would be very bad here. And then when I multiply by their SIP, here's my new denominator, and that would be a positive 3 over 2, or 1.5. Okay, that's my domain. X cannot equal those numbers. All right, now that's good to go. Why don't we go ahead and see now, is there anything in this step in blue that I can cancel? Do I have any of the same factors? Again, I don't. These stink. I'm going to come up with some better examples where they really do, because this is kind of boring. I'm not going to lie. How about x plus 6 times x all over 4 times 2x minus 3? Yep, nothing more I can do. Oh well. Let's find some better examples. Hopefully those first two were pretty good. All right, these will be more fun. All right, here we go. How about a basic one? Why don't you go and pause the video and try this one, because most of the hard work has been done already. Can you see you've already got one fraction on top and one on the bottom? All right, go for it. Now when I play, I'm going to go ahead and just right away, let's change our dividing into multiplication. This becomes 8 over x squared y times the reciprocal of the bottom. Good. Shall we check our domain over here? What can x not be equal to? Okay, let's find some denominators there. Okay, there, at x that would be bad there would be basically x equals 0. That would be bad. Same thing over here in this denominator. X equals 0 would be bad. And then once I did the reciprocal, I just have 12. So that doesn't really do anything. I'm not worried about that. Now, it's kind of interesting. We have another letter here. We should maybe talk about the domain of that letter. What y values can we not plug in? And similarly, if you look back up here, again, what y value would be bad there and what y value would be bad there would also be 0. 0 for y would make both denominators equal to 0. That's bad. So there's our domain. That was kind of interesting. We don't usually have 2 letters, but just for fun, we can check it out. All right, now we can go back over here to the left side. And now, ooh, sweet, now I can see some canceling and factoring that I can do. Okay, there's no real strict factoring with parentheses, but can you just look at the numbers per se? Look at the 18 and the 12. What can I divide out from both terms? How about a 6? All right, so the 18 becomes, and the 12 becomes, ooh, that was cool. How about the x's? Look, I can cancel the x's diagonally, so I can take away 1 from here, and I can take away 1 from here, and I'll just be left with x to the 1. And notice I have basically 1y and 1y that both die. All right, final answer. Now, after all that, what's left up on top? I think it's just a 3, because the x's and the y's on the top just canceled. Now on the top, I'll put the number first, and then just the x. Everything else is dead. There you go, folks. Oh, that was more fun, wasn't it? Now we could cancel terms better. We got our domain check beforehand, though, so we're good to go. Next one. You ready? Oh, yes. All right. So, again, good news. We have one fraction on top and one fraction on the bottom, so all the major hard work is done. Now we just need to multiply by the reciprocal. Okay. So, shall we do that right away? Let's see. Let's put this into multiplying by y squared plus 3y minus 18 over 2y squared plus 2y minus 12. And I mean 12, I mean 24. I was going to write 24. Did you see me change that? Mr. Brown, what's up? Oh, I'm going to write 24 again. Mr. Brown, dude, seriously, focus. Awesome. Okay, so basically, in all intents and purposes, that's gone. We're now changing it to multiplying by the recip. Okay, well, this is pretty cool. Again, we should probably try to factor everything. So let's look on the top here. And I mean, we've got 4 things to factor. We're going to get busy. Here we go. Let's take out a minus 4 here. Leftovers, I get a y squared minus 16. If I divide 64 by negative 4. Ooh, that's really, how about difference of squares? So it's really going to be minus 4, y plus 4, y minus 4. Okay, that's cool. That's the top. Okay, over here, if I take out a 2, I'll be left with y squared minus 3y minus 4. Oh, that factors more. I know it. How about y minus 4y plus 1? Yeah, all right. Okay, how about over here on the top right? Okay, this is just basically factoring here. A value is 1. So how about y and y? And what do you think? Maybe like a plus 6 minus 3? You do? Okay, me too. How about in the bottom right? All right, I can take out a 2. Y squared plus y minus 12. Well, there's that 12. That's what Mr. Brown's brain was doing. He was ahead of his time. He was in the future. No, he just wasn't thinking. Okay, 2. All right. Now, basic factoring here about y's and y's. Well, let's see. How about, do you think maybe a positive 4 and minus 3? Do good minds think alike? Okay. Now, if we can really see it, here's our new top left, our new bottom left, our new top right, our new bottom right. Okay. And remember, now we're back to earlier in the section where we're basically just going to be multiplying or dividing and canceling terms. But first, we need to look for a domain. Okay, our variable here is a y, right? So let's look at every single denominator. Okay, here, that's a denominator. What y values would be bad? Well, you've got the 2 in the front. That doesn't do anything because 2 can never equal 0. But look at y minus 4. Can't equal 4. Y plus 1 can't equal negative 1. Okay, let's go over here to this denominator, meaning this one that we factored. All right, there's a negative 4, and there's a 3. But, do you remember way back in the original problem, this was originally a denominator, right? Even though he switched into a numerator, he still was a denominator, so he's still holding on to some bad stuff. So let's look at that numerator over there, and I know that y plus 6 would give me, and y minus 3 would give me, again, another 3. Okay, so here we go. Wow, there's 5 bad numbers. Bad numbers. Okay, now, are you ready to cancel? I am, but to be honest, this is a mess. So can I maybe I can rewrite it over here. As you can see, this comes from a really cool Mad Libs game that we're going to play later, but maybe we'll see the answer right away. All right, let's change it colors to brown because it's Mr. Brown. All right, now we're going to change this whole friend up here, factored, and put it down here. Ready? This is fully factored. Okay, that's the top left. The bottom left was multiplied by. The new top right was, getting excited, things gonna cancel. I know. Hold on, wait for it, wait for it. And then the bottom right was 2 times y plus 4, y minus 3. Are you excited? All right, we did a domain check already, so we don't have to do domain. We already did it. Now, okay, I'm going to do numbers first. And do you see that I can cancel the 4 with the 2? Ooh, and the 2 over here. So the 2 2's on the bottom is 4. That cancels the 4 up on top. I still have the negative sign, so be aware of that. But the numbers are gone. All right, how about either top and bottom? Okay, how about y minus 3? Poof, poof. And let's see, over on the left fraction, how about y minus 4? A poof, a poof. Now, anything diagonally that I can cancel? Oh yeah, I see y plus 4. A poof, a ksh. Canceling should be violent. I think it's exciting because those things are gone, baby. All right, on the top, what is left? A negative sign and a y plus 6. And on the bottom, the numbers were gone. I'm just left with y plus 1. Now, let's just check and see. We did domain already. That's great. Is there any more canceling to do? I don't think so. And it's kind of funny that you just happen to scroll down and look at that. The answer is right there. It was A. If you look at all the other choices, they're all really similar, but they didn't deal with the negative sign as well as we did, because you guys are the best. So again, that negative sign came from over here, and he moved right over and was there. You could distribute the negative if you want to distribute the negative, but I like it to keep it factored, so I like the way we kept that answer. That one was really fun. Okay, let's do one more that is not as easy because you're going to need to make one fraction on top, one on the bottom, before you think about multiplying by the reciprocal. Okay? Pause in the video, try it on your own, and I'll see you back here in a minute, guys. Good luck. All right, let's see how you did. Let's just focus on the top here. And let's see. I need to find a common denominator between the two of those. I have 4d and I have d. Well, I think if I multiply the right fraction by 4 top and bottom, that would really easily give me my LCD of 4d. So how about this becomes 3 over 4d minus 2 times 4. We got 8 on top, and there's our common denominator of 4d. So how about now? We got our common denominator, sweet. And our top is 3 minus 8 is just negative 5. Okay, that one's good to go. Let's sit and chill. On the bottom. Okay, this denominator, I've got d and 2d. So I think really easily I can multiply the bottom left one, top and bottom, by 2. Okay, that would give me about 2 times 1 over my LCD plus 3 over my LCD So there's my LCD of 2D, and on top I just basically have 2 plus 3. I like that we just have numbers here. That's awesome. Okay, that's good to go. Now let's rewrite this, friend. Ready? Here we go. The new top is negative 5 over 4D. New bottom is 5 over 2D. Great job. If you got there, well done. Pat yourself on the back, but don't hurt yourself. Okay. Dividing by a fraction is the same thing as multiplying by the, here we go, times, let's flip the denominator, multiply by the reciprocal. Great. Ooh, I see things canceling. But wait. Domain, please. Okay, our variable here is D, so our domain is D. All D's, that D can't be what? Okay, denominator. Here we go. 4D, the D that would make that bad, would make it 0, would be actually D equaling 0. So that's bad. We can't have it. This denominator, same thing. Same thing, right? Because that D, if that equals 0, then it would make that denominator 0. And then when we flipped and inverted and multiplied by the recip, this is my new denominator, but that's just a number. That's 5. He'll never equal 0 as much as he tries, so we don't have to worry about it. So our only bad value here is if D is 0. So D can't be 0. Okay, ready? Now, can we go back to our answer down here, and let's go ahead and destroy things. I see numbers. I see 5 and 5. Poof is 1. Poof is a negative 1. Keep the negative. How about the 2 and the 4? Poof. Poof. Oh, look at those D's. Oh, I have one D on top and one on bottom. Bye. Bye. And you're left with, okay, after this destruction, on top, I'm just left with, basically, a negative 1. And on the bottom, look at all the stuff I canceled. I basically just left with 2 times 1, or 2. Wow. Did you ever imagine that this huge, massive, ugly, complex fraction would just turn into this little measly negative a half? That is so hot. Oh my gosh. Is the answer down here? Let's check and see. Oh yeah, baby. We're going to the playground. And there you go, folks. So complex fractions, they are really complex by name. But again, if you're okay with your steps, combine the numerator into one fraction. Combine the denominator into one fraction. Multiply by the reciprocal, checking your domain. And then just simplifying all over the place. Great job, folks. That's the end of complex fractions, and that's the end of section P.5. Great job, friends. See you next time.